White Point has so many great geological phenomena to observe. Its diverse and unique selection is what makes it so fascinating for many in the geological community. But truly, something that's fascinated me are the anticlines that can be spotted near White Point, Royal Palms. Which makes sense, as the unique rock formations is one of the biggest draws to this beach. Anticlines are a phenomenon when rocks form in the shape of an A or an arch, the older rock usually being found in the core of these structures rather than uniformly layered, as is typical. The creation of these folds are often the same. As quoted from California State University Dominguez Hills in 2018, the Department of Science said, quote, "This geological deformation is due to compression caused by plate tectonic stresses." End quote. The tectonic stress and pressure from being pushed together is what can cause an anticline to form. The more stress and force, the larger the anticline. This can be easily visualized by imagining two pieces of carpet. As they lay flat on their sides, the carpet being forced together that was once flat is now being raised into the shape that may resemble an arch. It is a crude analogy, but it holds true to how anticlines are formed and why they get the particular arch shape that they are known for. Palos Verdes is located on a fault line, and many anticlines that are found at White Point are parallel to the Palos Verdes fault zone. The reason for this is simple. As stated before, tectonic stress and pressure is what can cause an anticline to form. Therefore, so many being parallel to the fault makes complete sense, as when you think about it, as the fault line shakes and presses outwards, the anticlines feel a growth of pressure from their respective sides, again causing that arch to form as both sides compress together naturally. As stated in a report done by the California State University of Long Beach, quote, "The compressional forces in the landscape under Palos Verdes creates an anticline here, a bunched up pile of originally horizontal marine and alluvial beds." End quote. These anticlines being near and parallel to active fault lines makes the anticline more visible. The fault line will naturally aggravate the anticlines whenever seismic activity happens, and it will inevitably force more pressure onto the anticlines, making the arch turn further inwards. But beside anticlines, there are so many unique and fascinating geological phenomena available to be observed near White Point.
Since we just talked about how the Palos Verdes fault shapes the rocks at White Point, I'm going to jump into the things that formed because of all the fault movement, which was the old White Point hot spring. So White Point today looks like a normal beach, but it actually used to have a natural hot spring bubbling right next to the ocean. And the whole reason it existed was because of the Palos Verdes fault zone. Because the rocks around this fault are so fractured and cracked, they created these little pathways where water could move deep underground. So here's how it worked. Seawater and groundwater would seep down through all those cracks, and the deeper it went, the hotter it got. That's the geothermal gradient, meaning the earth naturally gets warmer the further down you go. Then the hot water would rise back up through the same fractures and reach the surface as a hot spring. Because it was so unique, people actually built a whole resort and mineral bath spa here in the early 90s. People really believed the hot mineral water was healing, so White Point became a little getaway spot. But the spring didn't last forever. Landslides and coastal erosion damaged the resort, and over time, movement along the fault probably shifted or blocked the pathways underground. Once that happened, the hot water couldn't reach the surface anymore, so the spring eventually stopped flowing. Even though it's gone today, the hot spring still tells us a lot about what's happening underneath White Point. That the area has active tectonics, fractured rock, and heat moving through the ground. Basically, the hot spring is a reminder that the fault is still shaping the land, even when we can't see it. Doesn't just create things like hot springs. It also lifts the whole coastal line over time. That uplift is exactly what creates marine terraces.
Not as large or widely visited as many of California's more iconic stretches of coastline, offers a uniquely rich environment for observing coastal processes up close. Its rugged cliffs, fractured rock formations, and narrow shorelines make it an ideal site to study how natural forces and human activity interact along the coast. This quiet beach has long been familiar with the challenges of coastal erosion and the many attempts to manage it. Erosion at White Point Beach results from a combination of human activities and natural forces that have gradually reshaped the landscape. One of the most significant human contributions to erosion along this stretch of coastline is the placement of homes, park facilities, and paved surfaces directly on the cliff's edge. These structures add substantial weight to the already fragile bluffs, increasing the stress on the underlying rock and soil layers. Development often replaces natural vegetation with concrete, asphalt, and compacted soil, all of which reduce the land's ability to absorb rainfall. Because the drainage system in this area is poor, water often accumulates within the soil instead of being diverted elsewhere, accelerating the breakdown of the bluff. Vegetation, which normally helps stabilize slopes by binding the soil with root systems, is sparse at White Point. The lack of plant life leaves the bluff exposed to runoff. Without roots to hold the ground together, even moderate rainfall can trigger small slumps and contribute to ongoing cliff retreat. Just above the shoreline, the city has invested heavily in hard stabilization measures to slow down erosion.
This fault shapes the land and even creates things like old hot springs. I'm going to focus on something you can actually see the second you step onto Royal Palms Beach: the rocks. And there's lots of them. Big boulders, flat slabs, rounded cobbles, gravel, and then patches of sand mixed in. And none of that is random. The placement of the rocks at White Point is basically a record of all the geological forces hitting the coastline at the same time. First, most of the rocks here come directly from the cliffs above the beach. The cliffs are made of layers of weak sedimentary rock, mostly shale and sandstone, that formed millions of years ago underwater. Because the area is sitting right on the Palos Verdes fault zone, those rock layers are tilted, folded, fractured, and constantly being pushed upward. That tectonic uplift makes the cliff really steep, and the fractures in the rock make them super unstable. So when you see big boulders on the beach, a lot of them are actually pieces of the cliff that broke off during landslides or rock falls. The huge 2011 landslide is a perfect example of this, since sections of broken pavement, house-sized chunks of rock, and smashed sediment layers slid all the way down to the shoreline. Some of these blocks are still sitting right on the beach and haven't moved much because they're so massive. Once the rocks reach the shoreline, waves take over. Royal Palms has strong waves that constantly reshape the beach. Strong waves lift and roll the smaller rocks, carrying them along the shoreline in what's called longshore transport. That's why you'll see long, curved lines of rounded rocks that seem almost sorted by size. The bigger boulders stay close to the cliff because the waves can't move them, but the smaller rocks get pushed south along the coast. There's also human influence. The riprap, those big armor-like boulders stacked at the base of the bluff, are placed there on purpose to slow erosion. When waves hit those boulders, they reflect energy and push smaller rocks around them, which changes the natural pattern of sediment movement.
Welcome to White Point and Royal Palms, one of the wildest spots on the Palos Verdes Peninsula when it comes to geological drama. Well, no better way to start this off than with the rocks. This area is mostly made up of Miocene-age volcanic rocks, specifically basaltic andesite lava flows, volcanic breccias, and tuff, all a part of what's called the Catalina schist basement. These rocks formed around 15 to 16 million years ago during a period of intense volcanic activity. You can literally walk around and see layers of hardened lava and ash that were once a part of undersea eruptions. Now let's talk about these cool marine terraces you can see on the cliffs. These flat, step-like surfaces were carved out by wave erosion when sea levels were higher in the past. The tectonic uplift slowly pushed them up over time. Each terrace is basically like an old shoreline, kind of like Earth's version of a timestamp. They're super important because they show us how sea level and land elevation have changed over thousands to hundreds of thousands of years. But with all this activity becomes instability. This whole area is extremely landslide prone. The rocks here are fractured, tilted, and often sit on top of slick clay layers, making them super weak. In fact, the White Point landslide in the 1980s literally destroyed part of the old road that used to go right along the coast. Even now, signs of ground movement are everywhere. Bent fences, cracked pavement, warped sidewalks. It's all a part of the ongoing motion caused by gravity, water, and weak rock layers just kind of doing their thing. So next time when you're hanging out here enjoying the view, just remember you're standing on millions of years of tectonic chaos, uplifted shorelines, ancient lava flows, and a ground that's still on the move. It's beautiful, powerful, and just a bit unstable, kind of like us all.